Alright, so let's solve the logistic equation. So we have dp over dt is equal to p times a minus b p. Correct. Alright, so let's go ahead and solve. One thing that's really nice about this is that it's a separable equation, so we're going to go ahead and get everything onto the left-hand side. So we have dp over p a minus bp, and that's equal to just dt. Now, once we have all of our p's on the left side, all of our t's on the right side, we're going to go ahead and integrate. So, let's go ahead and put some integration in. On the right-hand side, it's really easy. It's just going to be t plus c. On the left-hand side, we got to differentiate, and we have kind of a 2-degree binomial, but it's factored, so that's nice. But what we're going to have to do is integration, not integration by part, but do partial fractions. So we got to get, so we're going to go ahead and separate this into partial fractions. So our first one's going to be 1 over a divided by p plus b over a divided by a minus bp. Then that's going to have dp on the outside. Alright, so now let's go ahead and integrate the left-hand side. And so when we integrate, I'll just keep the same color. When we integrate, we're going to go ahead and integrate the left 1 over a over p. It's just 1 over a natural log absolute value of p. And then when we integrate the right-hand side, have b over a. When I take the derivative of the bottom a minus bp, it's just going to be negative b. So when I plug in the negative b, I have to also take that out. So b on the bottom, we'll cancel out the b on the top. So we're just left with minus 1 over a natural log a minus bp. And that's equal to t plus c. Alright, now let's go ahead and try to write this without, we're just going to write this all together. And so we're going to have 1 over a natural log, and then we have p divided by, since there's subtraction, so we're just using rules of logarithms, natural log of p divided by a minus bp, and that's equal to t plus c. Alright, let's go ahead and get rid of that a. Let's multiply a to both sides. So we get natural log of p over a minus bp is equal to, multiply a times c is at, multiply a times c is just going to be c. After we multiply that, let's get rid of our natural log. So we're going to put e in there. Once we put e in there, we're going to be left with p over a minus bp. And that's equal to e to the at plus c is going to be c e to the at. And then now let's go ahead and solve for p. So I'm going to multiply a minus bp to both sides. So p is equal to a minus bp times c e to the at. P is equal to a c e to the at minus b p c e to the at. Now, I'm going to go ahead and bring that back over to the left, the term that has the p. So p, plus b p c e to the at is equal to a c e to the at. Pull out the p, and so p 1 plus b c e to the at. So now p is solved for. A c e to, well, p is by itself. So now we're going to divide both sides. And when we divide both sides, we'll get p is equal to 1 AC e to the AT all over 1 plus BCE to the AT. All right, now we can simplify this even more. So let's go ahead and simplify it. We have an e to the AT term on the top and the bottom. And so let's get rid of that e to the AT by, what we're going to do is multiply the top by e to the AT, like 1 over e to the AT, and the bottom by 1 over e to the AT, just so that we can get rid of that e to the AT. And when we do that, we're going to get, and then I'll just point it up here where we're going because I'm running out of room. P is equal to AC divided by, and then we have e to the negative AT plus BC. And that's going to be our solution to the logistic equation. Right now, we're going to continue to manipulate this a little bit more, but we're going to do that right underneath. So, as t goes to infinity, so as time increases, all right, P of t is going to tend towards A over B, which is equal to K. So remember, K is the carrying capacity. So if we take our function right here that I've just boxed up, and we're taking the limit of that, we're taking the limit as t goes to infinity of P, all right? Well, P is just AC over e to the negative AT plus BC. Well, as our term, as t goes off to infinity, that's getting closer and closer and closer to 0. So therefore, since that's tending towards 0, we're left with AC over BC. C's cancel each other out, and so A over B is going to be our carrying capacity. Logistic curves are accurate in predicting growth patterns in limited space of certain types of bacteria, water fleas, and fruit flies. If P of 0 is equal to P sub 0, then we can rewrite this equation even more. So let's go ahead and say that P of 0 is equal to P sub 0. Then we can say P sub 0 is equal to our function AC sub 1 up there. So AC, or we can just say AC, over e to the negative a times 0, since t's are 0, plus BC. And so that's going to turn into just AC over 1 plus BC. And we're again told that that's going to equal P sub 0. All right, so let's go ahead and solve for that. And so I can multiply the 1 plus BC over to the right-hand side. And then I'm left with just AC is equal to P sub 0 times 1 plus BC, which is just going to be AC is equal to P sub 0 plus P sub 0 BC. And now I can solve for my constant. So let's go ahead and solve for the constant. Let's go ahead and bring over the P sub 0 BC to the left-hand side. So it's AC minus P sub 0 BC is equal to P sub 0. And pull out a C. If we pull the C out, we're left with A minus P sub 0 times B equals P sub 0. And so we found our constant. Our constant is going to be c is equal to p sub 0 all over a minus p sub 0 b. All right, now we can plug that back into our equation. Again, yeah, this is fun. What I'm doing is we're breaking it down so where all you have to do is now just plug things into the logistic equation, and your solutions will be much easier. So, plugging in p sub 0 divided by a minus p sub 0 b into our equation right here, we're going to substitute in for c. We're going to get p is equal to a times p sub 0 over a minus p sub 0 b divided by e to the negative at plus, I'm going to say p sub 0 over a minus b p sub 0 times, and then what was that? So times b. Alright, so now what we can do is we can get rid of everything by multiplying everything by a minus p sub 0 b on the top and a minus p sub 0 b on the bottom. Alright, so when we do that, on top, p is equal to a p sub 0 divided by, and then we can have, I'm going to change this up. I'm going to put this term kind of in front. So I'm going to do that term first. So when I multiply, I'm just going to get b p sub 0 plus, and then a minus b p sub 0 times e to the negative at. And that is our logistic solution. Alright, let me rewrite this p of t real quick. Alright, and so this is what we're going to be going back to a lot. So again, everything based off of our logistic equation, which leads us to what I just boxed up, which is our logistic solution, which is going to be the function that we're going to be using. Alright.